one by one. Okay, it is we know that chemical reaction. That is, it is important to learn two things about chemical reaction: whether the reaction occurs spontaneously or not. Which chapter will deal this one? This point? Can anybody tell me? The spontaneity of a reaction is explained by thermodynamics. Am I correct? Thermodynamics explains the spontaneity of a reaction, whereas delta G must be negative. Okay, I will share this one in the Google Classroom today. Please download it. Okay, that is, it is important to learn two things that thermodynamics deals. First one is delta G must be negative. Okay, but thermodynamics does not explain how to which extent the reaction will take place. It is not going to explain to which extent the reaction will take place. Therefore, chemical kinetics is required in that case. Chemical kinetics will explain to which extent the reaction will proceed. Okay. Thermodynamics does not tell the reaction occurs fastly or slowly, but chemical kinetics deals with the rate of reactions. For coronavirus, what happened? I had given the same example. Generally, in order to produce a vaccine, 15 years will take place. But Covaxin, Covishield took place only in 2 years or 1.5 years, almost. Okay, that is, speed of the reaction is most important. Am I correct? Speed of the reaction is very, very important. The rates of and the mechanism of chemical reaction know through chemical kinetics. What is rate of reaction? Okay, this is Yadav sir notes. Day after tomorrow, Yadav sir is going to take the class also for all of you in thermodynamics. He want to revise. Okay, the same topic again for you. Yadav sir, I think everybody knows Yadav sir. Dr. Yelur Yadav. Okay, he is very expert in physical chemistry. In unit time, the chemical reaction, the concentration of reactant decreases. See here, the concentration of the reactants are decreasing here. Okay, the concentration of reactants are decreasing. See here. Can you see this slide? See here, the concentration is decreasing. In this graph, you can that is clearly explained the decrease in the concentration. Okay, whereas that the concentration of the products increases gradually. The rate of the reaction of reactants is minus dC by dt. Directly it is given here. Okay, and with respect to products, why can anybody tell me why it is positive here and in the first case it is negative? ఎందుకు ఇక్కడ మైనస్ తీసుకున్నాం, ఇక్కడ ప్లస్ తీసుకున్నాం? ఇట్లా డిస్కస్ చేద్దాం మనం. ఎవరైనా చెప్పగలుగుతారా? విత్ రెస్పెక్ట్ టు రియాక్టెంట్స్ ఇట్ ఈస్ మైనస్, విత్ రెస్పెక్ట్ టు ప్రొడక్ట్స్ ఇట్ ఈస్ ప్లస్. Am I correct or not? Why? I think I had to unmute you. Okay, can anybody tell me, please? Let us have a nice discussion. Almost all of our friends are explaining nicely all the aspects. Okay, Kavya, Deepika, Andar, Akila, Maunika, అందరు చెప్పారు కదా. మీరు చెప్పండి ఇప్పుడు ఎందుకు ఇక్కడ మైనస్ ఉంది, ఇక్కడ ప్లస్ ఉంది, ఎందుకు? విత్ రెస్పెక్ట్ ఇది ఇట్లా ఇవన్నీ ఇంటర్మీడియట్ లో ఉన్నాయి ఇవన్నీ. హలో,
రియాక్టెంట్స్ డిక్రీజ్.
వెరీ గుడ్, రియాక్టెంట్స్ ఆర్ డిక్రీజింగ్. వెరీ గుడ్ నాన్న, వెరీ గుడ్. ఇంకా ప్రొడక్ట్స్, విత్ రెస్పెక్ట్ టు ప్రొడక్ట్స్ వాట్ హ్యాపెండ్?
కాన్సంట్రేషన్ ఇంక్రీజెస్.
Very good. With respect to products, concentration is increasing. Okay, therefore the graph is in this way. That is, it is increasing. It is in the form of an hyperbola. That is, whereas this one is a hyperbola. It is with a negative slope. See here, products are decreasing, and here it is having a negative slope. With respect to the reactants, the slope is negative. With respect to the products, the slope is positive. Am I correct or not? Okay, we can explain the same thing. What is the slope here? Can anybody tell me where the slope comes into picture? If you draw a line, tangent, a tangent is drawn. If you draw a line that is tangential, means it is touching this at a particular point. For example, it had touched at this point, let us assume. The slope, if you take the slope of this curve is positive, the slope of this line is negative. With respect to the reactant, the slope is negative. With respect to the product, the slope is positive. Okay, that is about these graphs. Then now the question is that, my dear student, this question is always asked: what are the factors? What is rate of reaction? And explain the factors affecting rate of reaction is very, very important. Concentration of reactants. Okay, reaction temperature, pressure, solvent, light, catalyst. These are the factors that are going to affect the rate of the reaction. I think I had placed this one in the WhatsApp group to you. I had posted. I remember that, these notes. Today I will post it again. Please go through it. Okay. Very important factors affecting rate of reaction. First one is concentration of the reactants. Okay, reaction. Then second one is reaction temperature. Third one is pressure. Fourth one is solvent. Fifth one is light, catalyst. Is the sixth one. Now let us see one by one. Okay. Here, first of all, let us take up the concentration. As the rate of the concentration increases, what happens? First of all, tell me, what happens if the concentration increases? What is going to happen to the rate of the reaction? Can anybody tell me? Concentration of the reactants we are increasing. When the concentration of the reactants is increasing, what happens to the rate of the reaction? It also increases. Very simple. Okay. If వాటర్ ట్యాంక్ లో వాటర్ ఉన్నాయనుకోండి, చాలా ఎక్కువ ఉన్నాయనుకోండి, ట్యాప్ ఫోర్స్ ఎట్లా వస్తుంది? ఎక్కువ వస్తుందా, తక్కువ వస్తుందా? రియాక్టెంట్స్ ఎక్కువ ఉన్నాయి అంటే వాటర్ ఎక్కువ ఉంది వాటర్ ట్యాంక్ లో, అప్పుడు ఫ్లో ఎట్లుంటది ట్యాప్ లో?
Very high, sir.
Very high. That is, if the concentration is more, concentration of the reactants is more. For example, if you take a reaction, A plus B is giving products. Okay, if the concentration is giving C plus D, if the concentration of A and B is more, the reaction, the rate is also more, very high. Okay, at any instant, the rate of the reaction is directly proportional to the product of the concentration of the reactants in the state. In that state, according to the law of mass action, I had explained this one a number of times. Okay, that is, what is law of mass action? According to the law of mass action given by Guldberg and Waag, at any instant, the rate of the reaction is proportional to the molar concentration of the reactants, A, molar concentration of A into the molar concentration of B. Okay, that is the reactants we are taking. Okay, for example, if it is A moles of A is reacting and B moles of B, everything is there in the intermediate. Okay, R is equal to K into the same thing. K is a constant known as rate constant. This is known as law of mass action. At any instant of time, the rate of the reaction is directly proportional to the product of the concentration of the reactants at that instant. Rate of reaction is proportional to the product of the concentration of the reactants. Okay, then it is the rate of reaction is proportional to the product of the concentration of the reactants. A plus B is giving products. The rate of the reaction is proportional to the concentration of A into concentration of B. K is equal to rate constant. If the reaction is represented as X moles of A is reacting with Y moles of B, it is giving products. Then according to the law of mass action, V is nothing but the rate of the reaction. My dear students, you must remember here. Okay, V is nothing but the rate of reaction. Okay, instead of R, it is represented by V also. V is equal to K into A to the power of X. X is the coefficient in the reaction, and B to the power of Y. V is known as the rate of the reaction. Therefore, the order of the reaction is X plus Y. Then another one is effect of temperature. Have you understood this one, rate of the reaction with respect to concentration? Okay, are you thorough in this one? I think there is no problem in this case. Am I correct, students? విద్యార్థులకు నేను విన్నవించుకునేది ఏంటంటే, ఇది అర్థమైంది అనుకుంటున్నాను. అర్థమైంది కదా? కాన్సన్ట్రేషన్ ఈజీనే కదా, కంపల్సరీ వస్తుంది నాన్న. ఇది ఎఫెక్ట్ ఆఫ్ టెంపరేచర్. టెంపరేచర్ పెరిగితే ఏమైతే చెప్పండి ఎప్పుడైనా? ఫస్ట్ ఇది గుర్తుంచుకోవాలి, కామన్ సెన్స్ తోటి ఫస్ట్ ఆలోచించాలి. ఓకే, ఈరోజు ఈ సాయంత్రంలో మనము కెమికల్ కైనెటిక్స్ నేర్చుకుంటున్నాం. మీరు ఖచ్చితంగా డిస్కస్ చేయాలి. ఓకే, రేట్ ఆఫ్ రియాక్షన్ is directly proportional to the temperature. Any chemical reaction, rate is increased. Okay, rate is proportional to the temperature. Am I correct or not? Tablet వేసుకున్నప్పుడు టీ తాగుతారు, ఎందుకు చెప్పండి? లేదా వేడి నీళ్ళు తాగితే మంచిది అంటారు. ఆయుర్వేదిక్ మందులు అయితే వేడి నీళ్ళలో కలపండి అంటారు, ఎందుకు చెప్పండి? వాట్ ఇస్ ద రీజన్? కెన్ ఎనీబడీ టెల్ మీ? మ్యూట్ లో ఉన్నారా? హలో స్టూడెంట్స్, ఎందుకు టెంపరేచర్ పెరిగితే మెడిసిన్ కూడా యాక్టివిటీ పెరుగుతుంది? టెంపరేచర్ అంటే 100 degrees కాదు, బాడీ టెంపరేచర్ 35 degrees సెంటిగ్రేడ్ 25 మధ్యలో ఉంటే. మరి కూల్ వాటర్ తాగి టాబ్లెట్ వేసుకుంటే అది పని చేయదు. ఇది టెంపరేచర్ రియాక్షన్. Rate of the
reaction will be increases, sir.
Yes, rate of reaction increases. The assimilation of the medicine into the intestine is more. Okay, why? Because
It accelerates.
Accelerates. As temperature increases, the rate of the reaction also increases. For every 10 degrees centigrade temperature rise, the reaction rate is almost doubled. The reaction rate is almost doubled. For example, Kt plus 10 degrees centigrade by Kt is almost approximately equal to 2. The ratio is called the temperature coefficient. The reaction that relates the rate constant and temperature of the reaction was proposed by Arrhenius. K is equal to A into e to the power of minus Ea by RT. Okay, this is known as Arrhenius equation. This is known as Arrhenius equation. I think everything is there in the intermediate. Am I correct or not? You had come across all these issues in the intermediate itself. Same answer, only year change, that's all. Then, at two temperatures, T1 and T2, the rate constant K1 and K2. K1 is equal to A to the power of minus Ea by RT. Just now I told you that K is equal to A into e to the power of minus Ea by RT. The same thing. K is equal to A into minus e to the power of minus Ea by RT1. It is minus Ea by RT2. If you take logarithm, that is on both sides. Okay, on both sides, what is going to happen? K1 is equal to A is known as frequency coefficient, frequency factor it is known as. It is known as Arrhenius equation, my dear students. Arrhenius equation. In Arrhenius theory in electrochemistry, you had seen the same Arrhenius. See here, every area of physical chemistry touched. This is K2. At two different temperatures, we can write in the taking logarithm on both sides, natural log. Okay, log K is equal to log A into minus Ea by RT exponent. E is going to be withered out, removed out. And you add these two or subtract K2 minus K1. Minus E, this is the derivation of Arrhenius equation used to calculate activation energy. We can calculate the activation energy at two different temperatures also like this. Okay, very simple. That is effect of temperature means you have tried all this. First point is, as temperature increases, the rate of the reaction is going to increase. Second point is about for every 10 degrees centigrade rise of temperature, the reaction rate is doubled. Okay, the reaction rate is doubled. That is second point. Third point is, that is about the activation energy. Arrhenius equation you have tried. K is equal to A into e to the power of minus Ea by RT. Okay, that is log K, log A minus Ea by RT1, log A minus Ea by RT2. Okay, that is log K2 by K1 is equal to minus Ea by R into 1 by T2 minus 1 by T1. Log K2 by K1 is equal to Ea by 2.303 R into 1 by T1 minus 1 by T2, like this. This is known as Arrhenius equation. Any doubts in this with respect to temperature? Temperature paina emaina meeku సంశయం ఉన్నట్టయితే నాకు వాట్సాప్ చేయండి. వాట్సాప్ ద్వారా మీ సంశయాన్ని నివృత్తి చేసుకోండి. తర్వాత మనము ఎఫెక్ట్ ఆఫ్ ప్రెషర్, పీడన ప్రభావాన్ని నేర్చుకుందాం. ఏమైతే చెప్పండి, whenever the gaseous reactants are there, again the same as concentration. Okay, if concentration, just now we had seen the rate of the reaction increases as concentration increases. Similarly, pressure also. The concentration and pressure are acting in the same coherently. Okay, that is here nitrous oxide is giving dissociating to give nitrogen plus oxygen gas. In this reaction, the initial pressure is P1 or Pi is the initial pressure. The decrease in the pressure is X. In time T is X. Then what is going to happen? It is Pi minus X is the final N2O. Partial pressure of N2O is P initial minus X. P nitrogen is X. Am I correct here? Same as reactants. Nitrous oxide we are taking. It is giving N2 plus O2. N2, that is nitrogen gas plus oxygen gas. Half oxygen gas. What is saying is the pressure in the time T is equal to 0 is Pi. After some time T, Pi minus X will be remaining. Why? Because X amount of nitrogen is formed and oxygen also formed by X amount. Okay, then what is going to happen? We know the equation. Okay, that is X is equal to, finally it is found like this. Pi minus 2 into P minus Pi. Why? Because here nitrogen is X, P oxygen is also half X. Total pressure is calculated. Total pressure means Pi minus X, X and half X. Okay, that is total pressure is equal to, it comes to Pi minus plus X by 2 and X is calculated. Just to go through the notes, I will send just after completion of this class. I will send these notes through the WhatsApp to you. Okay, very simple, my dear students. Why? Because we know that what is partial pressure? Can anybody tell me? It is a pressure of a gas with respect to the total pressure. Okay, that is total pressure is also taken. Why? Because we require mole fractions. Okay, that is a Pn2O. Pressure of nitrous oxide is Pi minus X. X is calculated in this way and Pi minus this one. It is 3 Pi minus 2P. Okay, that is finally, that is K is equal to 2.003 by T log this one. Okay. Any doubts in this one? We have to by heart all this. Okay, this part. Very simple. There is no confusion here at all. Don't worry. Any doubts with respect to pressure? Just first point is, as pressure increases, the rate of the reaction increases. When the reactants are in the gaseous phase, the initial pressure, there is a decrease in the pressure time T. 2.303 by T log A by A minus X. We know that A is that is amount initial. Okay, first order reaction, everybody knows, I think, 2.303 by T log A by A minus X. What is A here? At least this one you must be knowing. What is A? A is the initial concentration. Instead of A here, what is given? Pi is given, that's all. Then another one is A minus X is also required. What is A minus X? Can anybody tell me here? A minus X is the remaining concentration of the reactants. That is equal to Pi minus X. Pi minus X. X is calculated just now. 3 Pi. X is equal to 3 Pi. That is A minus X is equal to like this. See here, A minus X is, instead of A minus X, it is written as Pi minus X. Okay, this one. Now I think you got. Had you got it or not? If you understood this one, type 1 at least. If you don't open your mouth, you may be doing some other work. That's why you are not opening your mouth. Am I correct or not, students? Students? Ardhamainda, Madhu? Just now you are answering Madhu. Had you understood this one? With respect to the pressure. Okay, very good. Very simple. Madhu, are you there or? Then let us move on to the solvent. The reaction occurring in solution state depends on the nature of the solvent. Okay, that is a constant of the solvent. The chemical reactions are classified into three types: ion-ion reactions, ion-dipole reaction, dipole-dipole reactions. Okay. Then, but the rate of the reaction is inversely proportional to the dielectric constant of the solvent. If the dielectric constant, which liquid is having highest dielectric constant? Can anybody tell me? What is a liquid having highest dielectric constant? Water is a liquid. Okay, log K is equal to log K naught minus this one. You remember this one, or just you have to tell me that rate is inversely proportional to the dielectric constant. Which molecules, which solvent will be having more dielectric constant? Whoever is polar. For example, water is a polar solvent. Polar solvents will have more dielectric constant. Okay, that is about the effect of catalyst. Then effect of light. Some reactions takes place only in presence of light. Okay, plants prepare carbohydrates in pressure of sunlight. In the presence of sunlight, we know that effect of light. You know reaction, that is effect of light. If light radiation increases, the rate of photosynthesis also increases. Is directly proportional to the intensity of light. Rate is proportional to the intensity square. ఒక వేప చెట్టు ఉందనుకోండి, వేప చెట్టు కింద చెట్లు పెరుగుతాయా? మామూలు ఇక్కడ పెరగవు కదా, నీడలో ఉన్న చెట్లు పెరగవు, అంతేనా కదా? ఎండలో ఉన్న చెట్లు పెరుగుతాయి. ఎందుకు చెప్పండి? వెరీ సింపుల్. The rate of photosynthesis is more when the plant is placed in the planted in light. Okay, that is about that one. The effect of catalyst. Okay, the substance, just I will read out this one, very simple. If the catalyst is, what is the main purpose of a catalyst? Can anybody define a catalyst? I think
It speed up the reaction rate.
Which
It's not
increases
involved in
the
the rate of
The
reaction.
catalyst is involved in speed up in reaction.
Speed of the reaction is increased. Without participating in the net reaction, the reaction rate increases. Speed, instead of, you should not call now speed from now onwards. You should call it as rate of the reaction. The substance other than the reactants present in small amounts, but and participates in the reaction and increases the reaction without itself being consumed in the reaction is known as a catalyst. In the net reaction, it is not used. It is participating in the reaction, okay, but at the end it is coming back. The reactions that occur fast in the presence of catalyst are known as catalyzed reactions. The catalyst and the reactions are present in the same physical state. The reaction is known as homogeneous catalyzed reaction. When the catalyst and the reactants are in the opposite phases, gaseous liquid state, they are known as heterogeneous catalyzed reactions. Can anybody give some examples of homogeneous and heterogeneous catalyzed reactions? For example, nitrogen gas is there and hydrogen gas is there. These are gases. Okay. What is going to happen in the presence of iron? They are giving NH3 gas. Ammonia gas is formed. Okay, that is the reactants. It is a solid. Therefore, such reactions are known as heterogeneous catalyzed reactions. What are homogeneous catalyzed reaction? N2 plus 3H2 gives 2NH3. Haber's process. This is also there in an intermediate. In a homogeneous means the same reaction N2 plus 3H2 in the presence of nitric oxide, NO gas. The reaction is taking place to give this ammonia. Therefore, such reaction is also known as 2NH3 is formed. Homogeneous reaction. It is known as homogeneous reaction. Okay, how the catalyst is functioning is also explained here. See here. Okay, that is here. What is going to happen is potential energy is decreased for the reaction. The reaction coordinates here, actually the graph it had to cross this uphill, the reactants to convert it to products. Let us assume that this is the reactant side. The reactants are nitrogen, hydrogen are there. It is ammonia. It had to cross over this uphill. But in the presence of a catalyst, the reaction, the uphill the height is decreased. See here, the height is decreased. Okay, this is known as the activation energy. Activation energy is decreased by a catalyst. Am I correct here? This is also known as activation energy for the catalyzed reaction, EA dash. Which is more, either EA or EA dash? EA is more. Activation energy of the uncatalyzed reaction is more than EA dash. Okay, that is about this one. This is about that one. Okay, that is about this reaction. This is very important question, my dear students. I will share just within the no time after this class in the WhatsApp. Please go through it. Any doubts? And another thing is there, that is derivation. See here, you might be seeing these notes. Derivation is there in our syllabus. Second order derivation is also there. But third order is not there in our syllabus, my dear students. Third order is not there. Zero order, you can read it. Order and molecularity, only order is there, but no molecularity in our syllabus. Okay, all this is not there. From page number, is there any page number for this one? ఇక్కడ నుండి ఇవన్నీ లేవు మనకు. Kinetics of complex reactions ఇవన్నీ లేవు. Okay, that is page number 11 నుంచి లేవు. Okay, that is about, you can go through them. I will share this one in the WhatsApp group. Any doubts, students, about that? These three questions are there, which are very important for you. Okay, if you are having any doubts, you can